Morning, Prob-Stats students. Mr. Mitchell here to take a look at percentiles and box and whisker plots today. So percentiles. Percentile always has to be a whole number between 1 and 99. P percentile of a distribution is value such that P% of the data fall at or below it. The percent falling above the P percentile will be 100 minus that. So you can never be in the 100th percentile is what that means. So if you score in the 80th percentile, that means you are equal or better than 80% of the people. That's what that means. So you may have seen percentiles on any type of standardized test score you've ever taken. That's typically where we see percentiles in school. Usually don't see percentiles in other regular testing or even other areas. That's typically where students would have come across it. So if you score in the 50th percentile, you scored better than 50% of the people, or equal. You can be equal to a group of people at the 50th percentile. So that's what a percentile represents. Here's just a little graph, a little example. If you're in the 40th percentile, 60% scored better than you, 40% you scored better than. Kind of the way it works. Talking about percentiles, then we get into quartiles. This leads us into our box and whisker plot. Percentiles, when we look at quartiles, we divide them into fourths. So we have a first, second, and third quartile. The fourth quartile is the max. It's the end of the fourth quarter. For any of you that pay any attention to sports, you know there's 4 quarters in football and in basketball. We would look at the end of the first quarter. The end of the first quarter, those are our quartiles, if you will. Okay, so the first quartile is at 25% of the data is below, 75 is above. The median is 50-50. The third quartile is 75% is below. Here's how we are going to construct a box and whisker plot, or I should say the information that we need to construct a box and whisker plot. We need our min value, we need our max, we need our median in the middle, which is the second quartile. Normally we just call it the median, but occasionally it does get called the second quartile. Then we have our first quartile and our third quartile. So this is called a 5-number summary. The 5 numbers that are important to find a box and whisker plot. Another thing that we do need to find is our interquartile range. You take the third quartile minus the first quartile. Okay? So computing quartiles, you're going to put the data in order. You can use a calculator to help with this process, but that's just what we have to do if we're doing it all by hand. Find the median first, second quartile. You just find the middle. We already looked at finding the median before. If there's an odd set of numbers, there is a middle number. If there's an even set of numbers, you take the 2 numbers in the middle and find the middle of those. Then you need to find the median of the first half. That's the first quartile. And then to find the third quartile, you find the median of the upper half. So you have to find half of half, which is a quarter. Find the upper quartile and the lower quartile. So numbers have already been put in order, so that's one less thing to do. So how many numbers do we have? 2, 4, 6, 8, 16, 17, 18, 19 numbers. So where is the middle number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. How do I know that? Because then there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers above. So 24 is our median. So median is 24. Again, just by counting, first putting the numbers in order, which was already done for you. There's 9 numbers above and 9 numbers below, so 24 is the median. Now we need to look at our lower set of data. So here's my lower set. So we said there's 9 numbers. So we need to find the middle of these numbers, these 9 numbers. So if there's an odd number, there will be a number in the middle. If there were an even set of numbers now, then we would take the 2 numbers in the middle and find the middle of those 2. So with 9 numbers, that means 1, 2, 3, 4 is to the left. 1, 2, 3, 4 is to the right. So 17 is our first quartile. 24 was the median. So our first quartile is 17. Third quartile, you need to find the upper half of the data. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. So halfway in between them is the 5th number. 1, 2, 3, 4, 5. 33. So our third quartile is 33. Now we have this IQR. I talked about this in another video just very briefly, that we were going to eventually find it. Well, today is eventually. To find the interquartile range, that's what IQR stands for. Yes, you can abbreviate. We just need to know what it represents. Interquartile range is when you take the third quartile and subtract the first quartile. So we're going to take 33 minus 17, and that's 16. So that talks a little bit about variability. It's also very important in finding outliers, okay, which we will talk about here in a couple minutes. 5-number summary. You need a minimum value, you need a first quartile, you need a median, you need a third quartile, and you need a max. Box and whisker plot is when you take those 5 numbers and you make a graph out of them. A graphical representation or presentation. So to make a box and whisker, you need to make a scale. So you need to include or look at the lowest and highest number. So I'm going to scroll back here a second. So when I make this graph, I need to get 12 and 51 on my graph. Everything else will fall into place. So I need to make sure I get 12 and 51 on my graph. Then I'm going to put 5 dots or 5 lines. You can also put vertical lines above the scale where the 5 values are. You must draw a scale. You can't just draw, like this can't be my box and whisker plot. I just can't do. I know that's a little messy, but I have no scale on that. So I need to have a scale. That's the first part. And that's sometimes what students forget to do. You need to have a scale, and you'll see the scale here on the next slide or two. You need to draw, you can put dots. You can put dots or vertical lines. So if you don't want to draw a dot, you don't have to draw a dot. You can just draw a vertical line to start. So here's 1 vertical, 2, 3, 4, and 5 vertical lines. Then we need to make our box. You need to make this box. And then you need to draw lines out to the ends. So this is our set of data. And so I got my scale. We went by a scale of 5. So 0, 5, 10, 15, 20, 25, 30, all the way up to 50. And notice you'll just estimate. So if this is 5, 12 somewhere right about in here. I'm sorry. If this is 5, this is 10, 12 somewhere right about in here. 2's are right about there. So we're just estimating exactly where they're at. If it's close, like is that exactly at 51? I don't know, it's close enough. And the only other thing that I would say here about the box and whisker, if you want to draw vertical lines here, you can, but you don't have to. So those could be included there. Okay? The only other thing that we need to worry about finding, and it's not directly on the slide, but we're going to do it right now, is do we have any outliers? So here's how we find outliers. We find our IQR. So we're going to take 33 minus 17, and we already found this on the other slide. That's 16. So to test for outliers, you take your IQR times 1.5. You have to do that. Oops. You have to do that first. So what's 16 times 1.5. That is 24. So this is like the magic number. What you're going to do, you're going to take the first quartile, and you're going to subtract this number. So 17 minus 24. And that's -7. Are there any numbers below -7? Well, what's the min number? It's 12. So is 12 smaller than -7? No. So there's none. So there's no outliers below. Now we have to do the same test above. You take Q3 and you add on 24. So it's 33 plus 24. So that's 57. So are there any outliers above 57? No. Closer than the lower level was. -7, that was never going to happen. 51 is still smaller than 57. So there are no outliers above either. So this is our outlier test. We need to find our IQR first. Then we take that number times 1.5. Is it always 1.5? Yes. Is it always going to be 16? No. So it's always IQR times 1.5. You get this number. You subtract it from the first quartile. You add it to the third quartile. And then you see, are there any numbers below or above these to find any outliers? So that's our outlier test. Let me know if you have any questions.